What's up, everyone? I was recently working on developing a knowledge-based LLM project. In this video, I'm going to demonstrate how to use that project. This is a web service which can be accessed by pulling the application's Docker image from Docker Hub. Once the container is launched using the image, it exposes a few APIs. One API endpoint allows users to store custom data, which is persisted in the database. Another API endpoint allows users to send prompts to the LLM, which will generate responses strictly based on previously stored data. The LLM is constrained to use only the stored content for answering, ensuring that responses are content specific and relevant to the provided data. Firstly, I will explain you the project setup using a diagram to make everything clear. This is the project setup. To use this project, we also need some other peripheral services. All the services are listed in dockercompose.yml file, which will then pull all the containers from the Docker Hub. First of all, talking about pgcaesar LLM middleware API. This image provides API endpoints which can be used to prompt LLM. For now, the application only supports Gemini 1.5 Flash. This image needs some environment variables like port and the API keys to access the LLM model, which are stored in llm-middleware.env. Further, we need Postgres 13 image to store the content provided by the users. Again, it needs some environment variables which are stored in postgres.env. Lastly, the image of the project. As other images, this also needs a few environment variables like port, Postgres host, Postgres port, which is the port on which the database is hosted, and the LLM API, which is the root domain to access the APIs provided by the LLM middleware API. Other than this, it also requires all the variables of the Postgres database so that it can connect with it to store all the data. Finally, the system design is such that the user would be able to store and manage content using the API endpoints provided by the project. The project will store the content into the database and return a unique key to the user for the stored content. The user can further use this unique key and prompt the LLM to get response based on the content. The project will get the unique key, retrieve the data from the database, add the user's prompt as well as data into a prompt template and call the LLM middleware API to get the response from the LLM. Lastly, the response received is passed back to the user. Now, let me walk you through the project demo and documentation. First of all, to set up the project on your machine, make sure you have Docker installed and started. In a new folder, create a file dockercompose.yml. The first image which I listed is of LLM middleware API, and it is passed the file with all the required environment variables and their values. I am hosting this image on the port 7000. Secondly, I have listed a Postgres 13 image and passed the required environment variable file. For the values of the environment variables of Postgres image, you can give this any value you want. I prefer to prefix the keywords with the name of the project. I'm hosting this image on port 5432. Moving forward, the Postgres image requires a volume to store data. I prefix the name of the volume with the name of the project. You can name this anything. Finally, listing the content-driven LLM API's image and passing it the required environment variable files. The first one is the same file as of Postgres, and the second one is for the image. Here I am declaring the value of these environment variables under the environment. The value of Postgres host would be the name which you give to the Postgres services. The port would be the port on which the Postgres is running. Lastly, the value of LLM API would be the domain to access the APIs by the LLM middleware API. It would be the name of the service with the port on which it is hosted. Finally, list down all the volumes here at the end. Now let me turn all the containers on and run a health check on the application. Perfect. The application is running fine. Before demoing the project, let me walk you through the list of APIs offered by the application. Firstly, it provides REST APIs for fetching, adding, updating, as well as deleting the content. Last but not the least, it provides /prompt API to prompt LLM and get response based on the content. Coming back to the Thunder client, I will try to store some content using slash content. Here, I would try to store very bizarre content so that when we prompt the LLM, we know that the LLM is answering based on the content and not based on the already stored knowledge it has. So this is the content I am storing. The sun is currently trapped in my backyard. Tomorrow morning, I will take it for a shower and make it cool. I worry that it won't be able to rise tomorrow and people will get scared by I but I guess I am doing a good job at showering it. It has got too hot these days. So I will store this content using this API and make a post request. Here is the API key which I get for storing the content. So I can copy this API key and then use this API/API/prompt with the updated API key of the content and make a post request along with the question which I want to ask. First of all, I will ask, will the sun rise tomorrow? It says that sun will not rise tomorrow because if you remember the content which stores says that it won't be able to rise tomorrow. Now for the next question, why will the sun not rise tomorrow? The sun will not rise tomorrow because it is trapped in the speaker's backyard. There you go. Now again, I'll ask one more question. Does sun takes shower? Yes, there you go. It returns the answer based on the content stored. Further, let's try to ask the question out of the content. Ideally, it should return the response that it is not trained to answer this question. Does moon takes shower? I'm not trained to answer this. Perfect. Well, it seems working. However, it has certain flaws which I'm going to discuss later on. For now, discussing about the use cases of this project. The one use case which comes in my mind is for adding AI chatbot in your already existing project. For example, if you have a personal portfolio or a project in which you want to add a chatbot which can help users with their queries, you can use this project to store all the information about your existing project and then use the API to prompt the LLM all the user's question and return them with all the appropriate responses. Further, let me discuss some future development plans with this project. Firstly, I want to update the prompt template which I am using to get the response from LLM to make sure that it returns the best possible answer to the user's question. There are a few drawbacks to the current prompt template. Secondly, I want to update this application to store the session chat history for the user to make sure that the user can further question the response sent by the LLM and that the LLM has the context through the previous chats. Additionally, I want to use LangChain framework in this application to make sure that the LLM is only sent the relevant chunk of information according to the prompt of the user. This will make sure that the token size sent to LLM is decreased, which results in saving the cost of using LLM. Lastly, I want this application to support a variety of models so that the developers can choose the exact model which they want to use. Thank you for listening. If you can please leave a star on my GitHub repo, and also I would love to hear your feedbacks to improve the project. Have a good day. Bye.